Hello, today we are going to talk about the free Pascal compiler and the Lazarus IDE, which together form a free software alternative to Embarcadero Delphi. So Lazarus IDE, free Pascal compiler. So the free Pascal compiler is compatible with Object Pascal language as used in Delphi. The IDE looks like Delphi 7 with many MDI floating windows. And with the toolbar with controls. Okay. And similar to Delphi, you can create graphical user interface applications, a notepad, a calculator, line of business applications, rapid application development, access to databases, using a programming language that's really similar to what's used by Embarcadero Delphi, so Object Pascal. They have GUI designers for controls, non-visual components. The alternative to VCL, Delphi's VCL, is called Lazarus Component Library LCL. It's creates applications that can run on Linux, the BSDs, and Windows. Can access databases. Can use some third-party controls for and libraries for Delphi. Okay. And the compiler that's underneath this is called Free Pascal, FPC, Free Pascal compiler. Supports the Turbo Pascal dialect. Has a text user interface IDE similar to Turbo Pascal. Supports inline assembly language similar to Delphi and Turbo Pascal. So FPC started by implementing Borlat Pascal, and then also had support for Delphi's Object Pascal. Okay, the current stable release version is 3.2.2 for FPC, the compiler, and 2.2. I know exactly which, for the Lazarus IDE. So we will install both to have both the compiler. So the Free Pascal compiler has the text user interface IDE, has the compiler, has a make executable, has support for their own types of projects. Okay, and the IDE is the executable that is the IDE, the Integrated Development Environment GUI application. Okay, let's see how we download these things. So says Lazarus release 2.2.4 from September this year. Download now. Accept, takes me to SourceForge. And in here I can select what type of download I want. I'm on Linux x86-64. I could use this. So 224 and 3 deb packages. I'm on Kubuntu 22.10. So there's one for FPC, the compiler, this one. Then there's the source code of FPC. FPC is written in Delphi, in source code that the FPC compiler itself can compile, so it's self-hosting. And this is the IDE. Okay. And Free Pascal. This is its website. So says that the development happens on gitlab.com. gitlab.com/freepascal.org. They have the same separation between FPC, which is almost everything, and Lazarus, which is the IDE, the GUI Integrated Development Environment. Okay, so FPC runs on many architectures and operating systems, including DOS. Version 3.2.2. Downloads. AMD 64. Linux. SourceForge. And there's a tar for x86-64. Strange extension tar, not tar.gz or xz or something. Okay, and it's 87 megabytes, and everybody downloads this thing. Okay, so let's download this. Okay, it finished downloading. Let's look at this tar file. Extract, not z, vf. Okay, so there's an install script, and then there's the binary, so executables. There's the demo projects, I'm going to guess, and documentation, and an install script. It says version 3.2.2, and I cannot read the rest. I don't know what it does. Okay, so let's look at the binary. Alt backspace. Whoa, it messed up everything in here. So similar to any installer for Visual Studio or for Delphi, it has a ton of archives in there with the sub parts of the IDE or of the toolchain. So it's a Linux distribution, has ASPEL, has bzip2, has Cairo, has compressed HTML format, has dbus, has fast CGI for websites, FCL, which is the base of the VCL. OpenAL, OpenGL, Lua, a ton of libraries which are sometimes shipped by things similar to a Linux distribution, such as Cygwin or the Git on Windows installer, etc. SQLite SDL. Okay, let's clean this up. Okay, and now let's run the install. So, is it executable? Yes, it is. /install.sh, and says that it wants to install into /usr/local, which I do not want. Let's not pollute that thing. /home/ should be in /local, but it's going to pollute that thing also. So let's go to /opt/fpc. So I installed in tilde /.opt. Documentation different archive doc-pdf-tar.gz, and demos different archive demo.tar.gz. Okay. End of installation. Refer to the documentation for more information. Okay, let's go there. Okay, so it's this FPC directory. So what's in there? So there's binaries, FP, which probably is TP, so the Turbo Pascal. Let's see. How do we do that? Let's open a console. FP. Yes, it's the IDE. Do I know how to program? Impossible to see in this color scheme from console. F to save. Need to choose a file. Inside of bin, yes. Okay. Compile Alt F9. So total errors 2. String exceeds line. Because it's a double quote instead of a single quote. F to save. Alt F9. Successful, press any key. How do we run this thing? Let's put a breakpoint. Control F8. Run. Recompile it with debugging info, yes. It's stopped. Okay, we'll look at the text user interface application. That's the IDE similar to TP Turbo Pascal some other time. Okay, there's FPC make, which is probably the make executable, the hello file that I just generated. So it outputs to standard output hello world. It's executable. There's converters, pass to JS. What else was in here? Okay, so these are the executables for the compiler and probably the assembler, the make file, and for resource compiler, etc. Okay, what else do we have? Documentation. I see the extension pp. Okay, let's head now to back to Lazarus, the IDE. Okay, so there's the standard application framework, which is LCL. We saw an FCL in there. This thing, units FCL registry process res. So the LCL is modeled after Visual Component Library VCL. Works on Windows, but not only. Okay, and written in Pascal for Pascal. So both the IDE is written in Pascal and the FPC free Pascal compiler are written in Pascal. And both have some compatibility with Turbo Pascal source code, with Delphi source code. Okay. And on Linux, they use Qt5 or GTK2. And GTK1 is available but deprecated, and GTK3 is available but experimental. Okay. So instead of downloading the 3 deb files and installing them for Lazarus IDE, I installed them from my Ubuntu distribution repository. Okay. So I find LCL GTK2, LCL Qt5, Lazarus IDE, Lazarus IDE GTK2, and Lazarus IDE Qt5. Okay, let's filter this list by Lazarus. So I can choose between this Lazarus minus ID minus Qt5 or Lazarus minus ID minus GTK2. So I went with Qt5. Okay, so it installed FPC, a ton of libraries, LCL libraries, other debs for third-party dependencies. And now I should have Lazarus in my start menu. Probably under development. This is it, Lazarus 2.2.0. So it's not the latest version, which is 2.2.4, but it's 2.2.0. Okay, so there's 3 different windows. It's MDI, the Delphi 7 style. The first one is the window title bar, the main menu, the toolbar with controls, and the toolbars with usual toolbar buttons such as save and open. There's the source editor window, which has tabs, and the UI control editor. And similar to later versions of Delphi, there's the possibility of saving your current settings, the way you configured your desktop. Okay, so let's create a Hello World application. File, save as. Into here. Let's see if it can create subdirectories. No, it can't. Okay. Why not? I save all. Okay. So let's look at the project files on the hard disk. So there's a file with the source code of the program, so that contains the end with the begin and end with dot. Which is this guy, so project1.lpr. Then there's the most important file, which is lpi. Which is an XML. Is the actual project. So the actual entry point to the hello project is the file lpi, not the file lpr. And then there's resources. There's the Microsoft Windows manifest. So this is for common controls. This is for post Windows. Okay, so this is the DPI manifest, the Windows 7 manifest. I don't know what these things are. So resources. Okay, the LPS, I don't know what it is. What is it? Unit, editor, index, window, index, top line, cursor, pause, usage. I don't know. LFM. So this is the similar to DFM so the design part of a class that represents a form or a frame or okay, using the same syntax as in Delphi. Okay, and then this is the pass file which contains the source code. These two together form unit 1. And here it's a declarative domain-specific language that creates the form and sets values to the properties of the form, such that you don't have Pascal Delphi code that shows the constructor and a bunch of assignments. Okay, and it's used by the GUI designer, by the forms designer. Okay, so really similar to what we have in Delphi. In Delphi we have pass files for the form unit. We have a DFM for the form in declarative language. We have a DPR for the pass file of the main entry point of the executable. This is similar to a dproj, and there's also resources, so really similar. And the syntax looks really similar for both the Pascal and the domain-specific language for the form editor. Okay, let's see if this thing runs. The project does not write debug info in dwar format. know, dwarf 3. What is this? Okay, and we have the application. So this is the IDE, the cheetah, and this is the actual final executable that we compiled using the IDE running. So it has this icon by default, which is project1.ico. And then what we expect, so the main application starts, which is this thing, and that creates the only main form of the application, which is unit 1, form 1, that gets created using a combination of the source code and the DSL, domain specific language, and this is the way it looks like. Execution stopped. Do not show this message again. Okay, so we're back in the IDE. What can we do in here? Let's make the form bigger. Let's edit the form. How do we do that? Error, unit not found graphics. All of a sudden, the unit graphics disappeared. Let's compile this thing. Build. Success. Now the unit graphics exists. Can we navigate to it? No. So in /usr/share /fpc source 3.2.2, so this is the latest version of FPC, /packages /univ int /src /controls. Universal interface. Univ int. Okay, a ton of if-defs because it's so cross-platform that it supports different compiler different CPU architectures and different operating systems. There's big endian and little endian, PowerPC and i386. Arch 64-bit, ARM 64-bit. Okay. Jump to interfaces, jump to interface uses. Jump to implementation. Implementation uses. There is no such thing as implementation and implementation uses. Initialization. Yes, there's such a thing as initialization. This is the initialization. Okay, so I don't know where the source code of the various methods are. external name set control pop-up menu ID. So it's in some other place. Okay. Forms. How do we see a control tree, a identifier tree? Object Inspector, Code Explorer, what's this? Okay, uses Mac types. Appearances. Constancy body color. Okay, color. Types. C tab pointer. Okay, interesting. Let's have this thing on the left hand side. Let's make this bigger. Let's have this with a bit of gap for the forms to be visible. Let's save the settings. Desktops. Save active desktop. Close. Okay. Cannot find implementation of what? Okay, so everything, all of the functions are external, and it's just a forward declaration of the class. No, just records. Okay, so can we build this thing? It worked this time. Okay. What controls can we put in here? A main menu. Not this. File. Help. Exit. Exit. So pressing enter allows to edit the caption of the menu or item or submenu item. Okay, that's about it. I don't know what this is. Control S. Control S saves the current file, correct? Let's build again. Okay. Control X does not work. Control S. The following methods used by dform are not in the source. Oh, where? In the DFM? Keep them and continue. Let's see the other file. Yeah, so it's in here in the LFM. There's onClick and the handler. So onClick is the event and the handler is menu item onClick. So this will make such that we can't compile. Okay. Some files have been changed on disk. Reload checked files from disk. Okay, file save all. Build. Run. And now we have a context menu. Let's make an about box. Menu editor. Help. Enter. About. And exit. Let's edit exit. So double click on exit. We didn't rename all of the identifiers, which is wrong. So let's do that. How do we do it? Name form 1, so this is main form. This is main menu. Okay. This is file. This is exit. This is help. And this is about. Okay, save all. Exit menu item click, so it also renamed the member, in this case exit menu item, which is what I wanted. And it also renamed the event handler, which is great. Application dot, what was it? Exit. Let's look at the pop-up window. So this application minimize. Application.terminate. Control S. Let's run this thing. File exit, and it terminates correctly. Okay, we're too far. We need to put this thing under version control. So let's find the gitignore file for Lazarus. Okay, so github.com/github/gitignore for Lazarus. Lazarus auto-generated files, RST, RSJ, Lazarus local file, user specific info LPS. So this thing, where are my forms located and on which line in the editor I am currently, and the history, etc. All of these things should not make it inside of the Git repository. Okay, let's go raw. Save page as hello, and the name of the file should be just gitignore. Save. Let's look at it. F4. So binaries, the local user configuration file, backup and lib, both exist in here, not on Mac. Rest, this is a binary, and it's excluded in here. Okay. So we can initialize a Git repository here in two ways, either from the command line or from Git GUI. Let's do it from the command line this time. Git init dot. Okay, so it says that the master branch is called master, which is okay. And now we'll do the first commit. We want the gitignore file. Project 1, this is the executable. Now this is a big problem. How can we exclude the executable? The ICO, we need it. The LPI is the entry point to the project. LPR is the source code of the main method of the function of the executable, the entry point of the executable. This is the only form that we have, source code and DFM, and we need to exclude the project 1 file. So let's do that. Okay. So for now we need to ignore the executable. The executables on so executable in the sense of the one file, which is binary, so it starts with ELF, is an ELF executable Linux style, and this is what's created by Lazarus IDE actually compiling the project. So project1.exe, which has the execute bit set, and because it doesn't have any extension, we can't easily exclude it. So if it had the extension .exe, it would have been already excluded by gitignore. But since it has no extension, how can we do that? I know. Project 1, Ctrl S. Let's look at the Git GUI again, rescan. So we said that the bulk of this file, the gitignore file, is actually taken from this URL. So when this URL changes, we need to edit and paste again the content from this URL to here up until here. And then we say that we have some customizations, which means that we also exclude this file project1 project one with no extensions. Initial commit is always the git commit message for the initial commit. Let's look at the history. So just one commit with many files added and with the correct git commit message. Okay, back to where we were. Let's create the about window. Do we have an about window already created for us? I don't know. Okay, we'll make one ourselves, then we'll do a tutorial. Okay, so the form editor, we edit the menu, we go to help about, we double click on it, it creates the event handler, which is called the main form.about menu item click, and in here we'll need to create a second form. Let's create a message box first. This simple quotes, not double quotes. Okay, Control S to save. Let's run this. So file exit closes the application. Help about shows a message box. And the message box actually is modeled to the window. You can't do anything with the window. You can't expand the menus or anything because it's blocked by this show message. So this is a minimal hello world GUI app written in Lazarus IDE plus Free Pascal compiler FPC. So it did line wrap. It automatically detected, computed the width for the window. Okay. Exit. How can we make this thing take just half of the screen? So such that we have space for a web browser window. Okay. So it tells us how to download and install Lazarus. If you're on Windows, you would need to do different things. So you go to download now, and where is it? Lazarus Windows 64-bit, Lazarus 224, and this executable, which I guess it is an installer. 64-bit version of Lazarus, 4000 downloads, which is a very large number. Okay, and then you follow the probably a GUI wizard to install the application. Okay, and then you start it from the start menu. It looks very similar to what's in here. Okay, you can place a button on the form, standard. This is the button. It's called button 1, which of course I do not like. What does the button do? Main button. It shows a message. Okay, so we have added the button, then it says double click on button 1, so in here in the form designer. It creates a event handler for the on-click event of the main button. And in here it puts a show message. Control S. How do we format the source code? Okay, like this. So source, Jedi code format, current editor window, Control D. Okay. Save the project file save, or Control S, or Control Shift S to save all. Compile the project, run compile. I never do run compile. If needed, I go run build. Look for your project. It's called project 1. So it's in here. 24 megabytes in size. Project 1 dot with no extensions. I click on the main button. It shows a model message box, which is centered to the window, not to the application. But still the application cannot be used because the model message box has hidden it. Okay. Okay, and then there are examples. Yeah, let's look at the examples. Where are they? /usr /share / I know, where are they installed? How do we find out? This thing, demo tar.gz. tar.gz, so that's It's going to mess this directory up. Tar minus struct zvf tab. These are the FPC demos, but I want the Lazarus demos. How do I do that? Uses Windows. Not okay. Just a second. Okay. So Lazarus IDE has access to the code templates. So we have the Lazarus IDE main menu, tools, and then example projects. And it says that examples reside in /usr/lib/lazarus and then the version. Okay. So let's see them. Combo box, LPI. Open first selected. So there is a begin end. The file is a .pp file. And the main begin that ends with a dot and with a that ends with an end and followed by a full stop has the main entry point of the application. So it says application initialize, creates the form 1, and then runs the application. So this starts the message loop, the busy loop, the main loop of the application. Let's run this thing. So we can't run it because it's in a read-only directory. /usr/lib is only writable by the super user, not by my user. So in here it creates a combo box and uses the with Delphi instruction, the keyword. Says with combo box 1, which is a local variable. Not a local variable, what is it? So it's a form that has as members labels, buttons, a main menu. Let's save these things. File save as. Okay, so the form doesn't have a minimum specified width and height, and is resizable. Okay, so it's a combo box. This is a combo box that's not editable. This is a combo box that's editable. This is an edit box. And this one is sorted alphabetically, and this one is not. So X item, add item, appears at the end, and at the end on the combo box that's sorted alphabetically. Where's the first item? Is the last one in the unsorted combo box, and the third from the end in the sorted one. File, quit. Okay, so it's in one file, in the file .pp. Where is it? Combo box .pass. In the file combo box .pass, there's both the end that ends with a dot and the program, so similar to the DPR file. Basically, this is the DPR file, this line and these lines. And this should be the form 1.pass file, whereas this is usually not defined using Delphi source code, but using that domain-specific language for specifying the layout of the controls, which is also edited using the GUI editor in Lazarus IDE. Here it says the name of the current method. Okay, so it's a huge method that just sets a ton of properties. Creates the UI controls in Pascal source code, creates them in the correct order, sets their properties, sets the event handlers, shows them in the correct order. Memo. This is a multi-line text edit. This is a combo box that it has the property sorted through. So standard controls.pass.pp, property sorted, which has a backing store, so a field, a private field, f sorted. It's private in the class the custom combo box, which inherits from the wing control. The back arrow works correctly. Jump back, Ctrl H. So when the property sorted reads, it just reads the boolean that's stored in the private field f sorted. But when you write the property sorted, you actually call the method set sorted, which is from the custom combo box, and it's virtual. I don't know where the source code that implements the methods is. In Delphi, you could navigate to the pass file, to the Pascal file that contains the implementation of the method, not just the definition of the method. So the implementation section has just 1, 2, 3 functions defined, and they're all free functions, not members. It says include a ton of inks. Custom group box, custom combo box, this guy. Okay. And set sorted. So it's in here. It seems that the Lazarus IDE can't navigate through include directives. So this directive, $uppercase I, means that similar to includes in the C programming language or the C++ programming language, take whatever content exists in this file and replace this line with the content that's inside of this file. So this is the content. Custom group, custom combo box.inc, and this one contains an interface. No, its interface is in the SD controls file. In here, there's not even the implementation section. It's just part of the implementation section of SED controls.pp. It's just implementation of methods from the custom combo box. Okay, this if then only contains this instruction on the then branch if the if ends before this line. Okay, so they use 2 spaces for indentation. They put the begin on the new line. So this is how an if looks like in Turbo Pascal, Lazarus and Delphi. If Boolean condition might not be surrounded with parentheses, then, and then the block on the then branch could be just one instruction, or could be a begin end block. This is how assignments look like. Assignments should have a space before them. This comparison should have spaces on both sides. So operators generally should have 1 space on each side. This is not okay. This is not okay. This is not okay. Okay, let's go back to, where was it, view? Code browser. Code Explorer, this thing. Can't we dock this? I would want to dock Code Explorer into Object Inspector. Okay. So where were we? Into the custom combo box. In set sorted. This one knows how to jump to the implementation. Okay, so set sorted receives a just one parameter of type boolean. When you assign to the properties, you set the properties sorted of the combo box, for instance, to true. This val will be true if val is different than the current value. So let's say it's not sorted and we make it sorted, then the new value and the old value are different. It assigns to the private member the correct value, which is true, and then calls update sorted, which update sorted is a private procedure, so a private member of the custom combo box. Okay. What does it do? So it needs to remember the text that's displayed in the combo box. So the combo box is in fact two controls. There's a edit box and there's a list view. In the edit box, it should not edit the content of the edit box, and then the content of the list view should be sorted. So in here it remembers what's in the text box, and in here it takes the string list, the list of strings which represent the list view, and it sets a sorted property to that thing, and then it finds the text in the text box, and then it sets to the combo box the item index, so it finds the current text that's in the text edit box in the list view, and it scrolls that list view such that selected item index is the current value in the combo box in the list view, and this also overrides the text box text. Okay. Let's see what's next. Example projects. Tab order text. File, save as. So it changes the extension from .pp to what's in the file save as dialog combo box, so to .pas. Okay, what's the tab order? The current element in tab order is close. Now the element is the tab page 1. Now the tab order is lost. If tab. Something does not work right. Maybe it's a Linux thing. Okay, so it has a PAS file and an LPI file. So this is the entry point of the project. This is the file that contains the two things, both the DPR, so the begin and with a full stop, entry point of the application, and the declaration of tform1. This is the executable. Okay, the same body for the DPR file, the LPR file, application initialize, application run, and application create, and the form to create. tform1 and the object of type tform1. Okay. Let's put breakpoints here and start debugging. So run F9, default F9. It stops on the very first line inside of the main function that's exported from tab order, the executable. Run F9, step into F7, step over F8, step out, shift F8. So we need F8 and F7. F8, F7. The application initialized, so it goes to the correct place, which is application.inc, which is a part of forms.pp. It doesn't use empty pair of parentheses. Doesn't use an empty pair of parentheses here or here, which I do use them. Okay, so this is the debugger showing the value of widget set symbol. Widget set class type. Is a T class. This is how you check equality. So if this type equals this type. So this is the Boolean operation, while this is assignment. So assignment is with colon equals, and equals comparison is just an equals, not double equals as in C++. Okay. The programming language is case insensitive, so you could have in here procedure all uppercase or procedure just uppercase P, the rest lowercase. It would work the same. But I like to have the correct casing. So if the type is case like this, where is defined, so uppercase TA and then lowercase pp location, then I'm going to use it like this. I'm going to keep the original casing for identifiers, and keywords I'm going to make them lowercase, which is what the source code from Lazarus does. Okay, on the screen, this is in fact the call of a function or a method or a procedure. F7. It's a procedure. Procedures don't return anything and must use the keyword procedure, whereas functions return something, this part, and must use the keyword function. You can't declare variables inside of the body of the function. There's a special var section, and there could also be a const section. And you can declare between this and this, you can declare another function. So you can declare a function inside of another function. And the embedded function has access to the variables that are defined in the parent function, in the function that embeds the embedded function. Okay, F8. Okay, create form, F7, F8. The application create form, so there's a type, which in our case is tform1, and out reference. So this is a local variable called form1, and this is in fact a constructor or a factory or something. So it returns this local variable starting from this type. In other programming languages, you must write out in here at the call site to specify that you know that the signature of the function expects that the second parameter is of type out. So out reference this thing. Allocates the instance without calling the constructor. Okay is a local variable. Some local variables, they capitalize all lowercase, others they capitalize with Delphi style, so an uppercase and then the rest lowercase. In here there's no begin, in here there's no end with a semicolon. There's no space around if or after if. And now we're back into our code. So this is the first party source code, the source code from Lazarus IDE and free Pascal compiler, whereas this is our own code. We create a label, we set properties to the label, and then we create an edit box. We set the properties to the edit box, the second edit box. Then we define tab order 0 and 1 between the two edit boxes. We say that both edit boxes accept the focus, so tab order, if you change the tab, the currently focused control using the tab key on your keyboard or shift tab. Okay. Then it says create page 2, which doesn't do anything. Then it says create page 3, which doesn't do anything. Then it sets the tab stop for the close button and makes that tab order 0. Right tab order F7. F7. So it actually wrote the tab order in the console. Where can I see the console? Listing row output. Okay. F8. And then we continue running. Something's not okay, but Delphi by default, or Lazarus IDE, has a GUI form editor, and that form editor should allow you to set the tab order in a visual, what you see is what you get manner. Okay. File, close all. Let's delete this example project. Example projects, what else? Progress bar. Save changes, no. File, save as, Control C, Control V, save, run, let's see how it looks like. Toggle smooth. Toggle text. Orientation. Quit. So the same thing, a LPI file and a PP file, which we saved as progressbar.pas. The same main function. And then defines a form named tform1. And here is the wrong capitalization for the type tform. Like this. Defines a member for each of the controls that it puts on the form. Events. And then these are the events handler. This is the constructor. Load main menu. Let's look with the debugger. So this thing. Load main menu. What's the call stack? So progressbar.pas, it's our source code in the function main, which has this strange name like $main, a hidden function. Then application.inc, the application.createForm, line 2176. Then progressbar.pas, our source code. And then tform1.load menu, which is our source code. Says the height and the width of the form. So this is a misleading name. Should be load GUI. Okay, so tform1.load GUI, the current function, which was called by tform1.create, which was called by tApplication.createForm, which was called by the main entry point of the executable, which is called by something B, which is not under our control. So it says the height and width of the window. Then it creates a timer, creates progress bar 1, creates 2 buttons, the 3rd and 4th button, sets properties to them. Text is called caption, event handler when you click the button. Some more buttons, the main menu with the item to close the application. So menu quit clicked, which does tform1.close, not application.terminate. And this is the correct way to do it. And then it finishes main menu. Okay, we're back in the first party source code from Lazarus and free Pascal compiler FPC. Okay, and now in application.run, which is the main loop. Which runs custom form.show, which does DPI things, sets visible true, and then show window, which does show window, which uses the Qt backend, Qt5 backend, in /usr/lib/lazarus/version/LCL, so not a VCL but a LCL. Interface is Qt5 Qtwin API.inc, which is part of Qtint.pp. Qt interface. Keep alphabetical. Okay, so let's see what this thing does. Verbose Qtwin API, so it has logging to standard output if you define this environment, define. This is a special variable that exists in all functions, so a function must return something. In this case, it returns a boolean. All functions that return something, or functions, have 2 special variables. One is called result, and the other is called with the name of the function, so show window. So you could go either show window, you assign it false, or to result, you assign it false. If you don't assign anything else to result or to show window, when the function will end, that will be the return value of the function, what you assigned last time to result or to show window. I always use result, never show window. This way I can rename functions more easily. When I rename functions, I need to change it in here. So in the implementation, I need to change it in the interface section. I might need to edit the docstrings and maybe some other places inside of the function. So it's way too many places. When you need to rename a function in way too many places, you need to rename that function. Okay, says Qt widget of hash of each window, so the handle of the window, show one. So it creates a Qt widget. And then if the widget is not null, it's not null, of course. We show normal. If has x11, yet it has x11. Set skip x11 taskbar. So very special code for the x11 server. In some cases, you need to make sure that the application does not appear in the taskbar. If it's a shown taskbar set to false, if it's a MDI child, so a tool window, a toolbar, if it's not a main form, so for your application, if your application has more windows, then just one should appear in the taskbar. Okay, and now it activates the recently created window and returns success. So at the very start of the function, the return value is set to the false, and only if no exception is thrown, everything works correctly. At the end of the function, it sets the return value with true, and only on this then branch of widget different than nil. And in here it runs it in the loop. So the application is visible right now. So there's a tick clock that ticks and increments the value of the progress bar. This thing, timer, T-timer. Has one event on timer, which calls the implementation of the event, which is called timed out. This thing. So it does things to the first progress bar that's defined. If it increments the step of the progress bar, it increments the position by the step. Let's see exactly what this thing does. So step is not defined, so then step should be So in here where the GUI is created, it creates a timer and doesn't set anything interesting to it. So it doesn't set any property, just implements one event. So that means that the step of the timer is the default one. Go back to the call stack and let's see what the step is. Step is 10 by default and position is some multiple of 10. So it was 10 and now it's 20. This is the increment instruction, which is the same as saying f position. To f position we assign the value of f position plus f step. Okay, and f max is 100, which is the default. If position more than f max, then it stops at f max. If position less than f min, which is 0, then position is 0. So it doesn't go out of bounds. And then takes self and sets the position to self. So tqts progress bar dot set position. Again in the Qt5 backend to the LCL Lazarus control library. Begin update, set new value, not 10 but 20. Set value, so it was 10. Now it sets the value to 20. And then end update. Update count, so with a counter. Begin update, end update. Qt objects.eas. Okay, so Lazarus IDE uses a first-party library of GUI controls that's called LCL, Lazarus Component Library, that has an API very similar to what's available in the standard non-Windows specific VCL in Delphi, and that runs both on Windows, on Linux, on macOS, on BSDs, because it has backends. So one of the backends is Qt5, there's GTK2, and GTK3 is experimental, GTK1 is deprecated. And probably there's another one for Windows, I guess. Win32. Okay, so that's about it. I have shown the call stack window, which allows us to jump into the call stack while we're debugging. We have the code explorer that allows us to jump into the implementation, so in files with extension .inc, which are $uppercase I, which means include in Pascal, which is similar to the hash include in C programming language or the C++ programming language, does the same thing. It takes this entire content of the winapi.inc file and puts it in here into lcintf.ps. in here, in this exact position. Okay, so this is the code explorer, has uses, procedures, types, variables, constants. And somewhere is the explorer of files, which I don't know which it is. There's a to-do list similar to what's available on Delphi. For that, you use the a comment and then to-do, all uppercase, and then colon, space, and then the text that you want to have as a to-do. Okay, you navigate by double-clicking in Code Explorer, or right-click, jump to implementation in Code Explorer. Then there's this navigator in Source Editor, the button in top left. So there's jump to interface uses, jump to implementation, and jump to implementation uses, jump to initialization. You can navigate back and forward in your history. This very handy button. So Ctrl H to go back. Okay, so this is the code stack when you're inside of the debugger. This is the messages, so the compiler errors, compiler warnings, issues, compiler progress. Then there's watches. In here you put expressions that you want to the debugger to evaluate. There's breakpoints. I have 2 breakpoints. So I really feel the need to dock all of these windows. Otherwise they're cluttering the entire space. So look at how many windows are in fact open and available with icons in the X11 taskbar. The old style MDI, multi-document interface. Okay. About the IDE. So it's installing the system using the packages from my distribution from Kubuntu 22.10. This is the compiler FPC. So FP is the text user interface ID, FPC is the compiler. Uses Qt5. Doesn't find the help. About box says Debian package. Okay, settings are in tools options. Only 2 things I would set, which is in the editor line wrap, but there's no line wrapping in Delphi, so there's no line wrapping in Lazarus IDE. And not MDI, so have all of the many windows that make up Lazarus IDE be tool windows inside of this, which are docked inside of the same window. Project Inspector, what is this? The list of units. There's no forms in this project. So wherever we are, project, view project source takes us back to the DPR file, to the .pas file, in this case LPR file. Okay, project options. Let's see what options do we have. So the DPI manifest, we have seen that thing. Scaling DPI, macOS Darwin. So this project does not have an icon, but the Hello one has. The title of the application. Just one form. This is the version info block, available in Windows Explorer in Windows if you right click on the file and go properties. Resources, no resources. PO probably uses getText to translate. So there's two debuggers, FP debug, internal dwarf debugger, and GDB. Web browser, pass to JavaScript. I don't know what this thing does, so it starts a server. The debugger stops automatically when an exception is thrown, so you can set the debugger to ignore certain exceptions just for this project. It uses the default paths. Current LCL widget set Qt5.